Hi class, let's take a look at example 7. And same as we did before, we're going to plug in a couple of actual angles and then see what we're actually getting. So we're looking at, this is going to be our theta. This is r is equal to 4 cosine of theta. And remember that we're obtaining r comma thetas. So I think we're going to have to make this a little bit larger. Okay, so let me start at technically 0. Let me get pi over 4. Maybe the values of pi, and just in case we may need pi over 3. Okay, so let me plug in the values. So at the first one, you're gonna have r is equal to 4 cosine of 0. R is equal to 4 cosine of pi over 4. R is equal to 4 cosine of pi. R is equal to 4 cosine of pi over 4. Okay, so let's start plugging some of these in and looking at the actual values that we're obtaining. So evaluating technically 0 for cosine, we're going to obtain 4. So this is going to be 4 comma 0. So your first coordinate point is going to be here. So it's at a radius of 4. So technically 1, 2, 3, 4. But it has an angle of 0. So that should be our first coordinate point. The second coordinate point, I'm going to go in terms of, actually, let me just do the pi over 4 is fine. Okay, so for the cosine of pi over 4, and obtaining this as a decimal approximation so that I can fit it in here. So this one I'm obtaining that it's approximately 2.83. So for this one, 2.83. So the radius is going to be at 2.83 at pi over 4. So let me actually write it as 1, 2, 3, 4. So once again, this is at 2 and a little bit of cash at pi over 4 around here. We're talking about a 45-degree angle. And then let's do at pi. Actually, let me fit in pi over 2 since it's going to be within the vicinity. So let me just put in pi over 2. And this will be r is equal to 4 cosine of pi over 2. And in this case, I'm obtaining 0. So for the pi over 2, we're looking at 0 comma, pi over 2. So in this case, it's going to be this coordinate point here, since it has a radius of 0 at pi over 2. And then let's go back at technically pi, but the pi one is going to give us a negative. So this one we're getting negative 4. So this one will be negative 4 comma pi. Remember that for these type of angles, so let me see. So 1, 2, 3, 4. And let me put in green where, remember that you first graph 4 comma pi. So in this case, that would be the coordinate point. Then adding pi, it's going to take us back at 0. Okay, which we already have, and that happens to be this one here. Let's do pi over 3. So and this one gives us 2. So we're technically looking at this one being 2 comma pi over 3. So not to scale, this is the angle 2 pi over 3, somewhere around here. Okay, so my sketch is definitely not to scale, but this one represents a circle, and I'll explain why in a minute. So technically, this is going to be our sketch, except that here my scale is not the best one. Let me try to fix it. So, uh-oh, that just made it worse. Okay, so let me try to fit it in here as a circle. Okay, a little bit better, not great. Okay, so this represents r is equal to 4 cosine of theta. Okay, so this is what I was trying to do. So I was just trying to double check that I am thinking on the correct one. So that's the correct actual, well, the correct shape up to scale. And let me go to the book. So this particular one, it's a circle. It's from a family of a cosine theta plus b sine theta, except that on the problem that we're looking at, the b is equal to 0. So just not to scale, but it's a circle on space. All I need is at least 3 distinct coordinate points, and that would be it. You're looking at problems that are very similar to the lecture in terms of what you would be graphing on a future examination. So this one is fine. It looked a little bit weird because of the scale that I was using as I was punching in the pi over 3 and the pi over 4, which not the best scale ever. But that would be your actual sketch.